Okay, so this is the second lecture on CAM synthesis. In this lecture, we are going to look at the type of the classification based on followers, and we'll also do a little bit of CAM language so that you become familiar with these aspects. Okay, so now, the classification can be based on different things. The first thing is to classify the followers based on the type of motion. Most of the cases, as you will see, a translating follower, so that's the typical case. But you can have what is called as a radial translating follower, in which case the axis of translation passes through the center of cam rotation. So when this happens, we call that as a radial follower. Now, if the translation axis about which it is translating back and forth is offset from the cam rotation, center of rotation, then we call that as an offset follower. And why we would do this will become clear as we do some of the synthesis aspects of it. So here's a pictorial representation. This is actually what is called as a knife edge follower, as the name implies. This is a very sharp point contact between the cam, which is out here, and the follower, which is translating back and forth. The axis of translation is passing through the cam center, so this is called a radial knife edge. Of course, we'll see the subsequent classification based on the type of follower. Based on the motion, it's a radial translating follower, and this is a case where the translation axis is basically offset, which is called an offset follower. You could also have an oscillating follower. So these are some examples where this is pivoted here, and as the cam rotates, the follower basically oscillates, rocks back and forth. So that is an oscillating follower, and so that is one more type of mechanism that you can have. You can also, as I said, based on the nature of contact. So the first classification is translating or oscillating, so the follower motion. So within that, I can have a translating radial follower, an offset radial follower, and then I have an oscillating follower. Based on the contact, you have knife edge and flat face, which I showed you. We go back to that same page. So in terms of the follower motion, this is translating follower. In terms of the type of follower, this is basically a knife edge. And this is called a flat face, as you can see, because the contact is happening with the face, which is basically flat. You can also have a spherical or a roller contact. So in this case, the oscillating follower has a spherical contact, and here this is a cylindrical roller. So these are basically a roller follower. So knife edge is very rarely used because because the sharp point of contact, the cam wears very quickly. So the wear and tear of the cam is very high. So you will not normally see these, but you will see the flat face or the roller or spherical being used more often. There are other cam follower systems, what are called as wedge cams. You can see this over here. This is basically as a wedge kind of translates back and forth. This moves up and down. So the cam itself is basically translating here as a wedge. Here is another cylindrical cam. So as the thing rotates, you have this basically moving along the outer periphery of the cylinder. So those are also cams. So that is possible. So then this is basically a type of cam, wedge and cylindrical cam, as opposed to the classical ones that we will be interested in. Then we have what are called as positive acting cams. So which means that effectively the follower requires a spring force to maintain contact. So the contact has to be maintained by force. So such cams are also called as force closed. So you can see all of these in all the four, we have a spring, because when it goes up, for it to be able to come down, I need to have a spring force to maintain that contact. Otherwise, kinematically, while it may be easy to say that it is in contact, when it moves away, there's nothing that brings it back. So I need a spring force here. So all of these cams show with spring loaded, and then they are called as force closed cams. So as opposed to these cams which are force closed, which are not positive acting, Then there are positive acting cams which do not require springs, and the geometry ensures that the contact is maintained. Such cams are called form closed. Form being the geometry ensures that it is closed. The example here is we have a Scotch yoke type system. So you can see here this is an eccentric circle rotating back and forth, and since this is fit into a frame like this, as it rotates the frame is basically forced to go back and forth, and this contact is always maintained. Similarly here, as this kind of moves into different positions, as it oscillates like this is always in contact because of the geometry that is involved. So you have geometry based or form closed, and you have force closed, which is a non-positive acting cam. Okay, some terminologies in the cam world. The first term that you need to get familiar with is something called a base circle. Now this is the smallest circle that can be drawn tangent to the cam profile from the cam center. So cam center is A. So the smallest circle. So here is the purple is the violet is basically the cam profile, and the smallest circle that can be drawn tangent to this circle from the cam center is basically called as the base circle. Now this is an important parameter in the cam design, because the size of the base circle basically determines the size of the cam. You can see that if I have a larger base circle, base circle radius, the cam becomes bigger. So the fundamental sizing of the cam is dictated by the base circle radius. So base circle, once again let me reiterate, is the smallest circle drawn tangent to the cam profile from the cam center. This is as far as the cam is concerned. Now to describe the follower motion, we have a point called a trace point, which is basically a point on the follower which describes the motion of the follower. So this is basically a theoretical point which we latch on to so that we can describe the follower motion. So in this particular case, I have a flat face follower, so you can see the face is flat. We describe the trace point. Now obviously any point on this follower, if you really look at this and follow, you will see that it is going up and down. So but we are going to particularly define the trace point as the contact point between the cam and the follower when the cam is at the base circle. Now you may argue, well, it may remain at the base circle for many number of points, so then it is going to be the point at which it takes off at this point and essentially starts to move. So when it is at the base circle, if all points are at the cam profile is the base circle, the follower doesn't move. So we'll define as the last point of contact on the base circle, and then after that the radius increases and then it starts to move. So basically for the flat face follower, this is artificially well, theoretically defined. I won't say artificially, it's theoretically defined as the point of contact between the cam and the cam profile, cam profile and the follower when the cam is at the base circle. So this is, you can see the cam is at the base circle, the follower is over here. We are not looking at the center of this as the trace point, so keep that in mind. The center of translation is not the follower trace point, although there is if you draw the motion, there's virtually no difference. But remember that we want to look at this as our lowest position and then trace everything from the motion of the follower from this point. You can also see I have drawn a case of an offset follower. The line of translation is away from the center of the cam. That's just an aside. So you have base circle, you have a trace point. Then we have something called a pitch curve. This exists only for a roller follower. For the knife edge or the flat face, we do not have this. This pitch curve is basically something that exists for a roller follower. First of all, for a roller follower, so that means here we have a circle. This is a circle, of course, representing the roller, which is a cylindrical roller. The trace point is actually the center of this roller. So you can see that the cam, this is going to go back, and EF is going to move up and down like this. So the point E, which is the center of the roller, is the trace point. So we track the motion of the follower using this center of the roller. For knife edge, of course, it is the cam profile. So the pitch curve is basically the locus of the uh, trace point motion, right, in the inversion, of course. So here the trace point motion, of course, is always going to be up and down like this. But if I were to look at the locus of all the trace points along the as the cam rotates, so that becomes the pitch curve. So if you imagine that I've frozen the follower, and in the inversion I'm imagining the cam to be rotating, then the locus traced by that point is going to be this orange line that you see. That's called the pitch curve. So now there is another term that is there. So pitch curve is basically, you can see that it is very similar to the cam profile. The blue is basically the cam profile. Obviously, the difference between this is the radius of the roller. So you can see they're parallel, with the pitch curve as well as the cam profile. We will see later how we derive the cam profile. So the pitch curve is basically the locus of the trace point motion in the inversion. And the prime circle, so we have a base circle which size the cam. The prime circle is basically the smallest circle from the cam center tangential to the pitch curve. So if I had a knife edge follower, remember that the pitch curve and the cam profile are the same. Therefore, the prime circle and the base circle will be the same. But for a roller follower, the prime circle and base circle are different by the radius of basically the difference between the prime circle radius and the base circle radius is the radius of the roller over here. So at this point, let's again summarize. You have now seen four terms. One is the base circle, which dictates the size of the cam, which is the smallest circle that can be drawn tangent to the cam profile from the cam center. You have trace point, which basically is a theoretical point which is used to trace the motion of the follower. For the flat face follower, it is defined as the point of contact between the follower flat face and the cam profile at the base circle when the cam is at the base circle. For the roller follower, it is defined as the center of the roller, the trace point. Now we have for the roller follower something called a pitch curve, which is basically the locus of the point, locus of the points traced by, the locus of the trace point motion in the inversion, assuming that you have fixed that and the roller is moving around, what is the locus of the trace point. So that is called as the pitch curve. And prime circle is basically the largest circle that you can draw from the cam center to this pitch curve. Okay, the next term that we are going to introduce is what is called as pressure angle. This is an important design parameter. Basically, it is the angle between the follower translation direction and the normal to the pitch curve. So here is, I have just drawn some kind of a pitch curve out here. So you can see here, this is the line of translation that we have, and this is the normal to the pitch curve. The angle between the line of translation and, so since it is offset at every point, this is called as an offset circle. So this is tangent, the translation axis is basically tangent to the offset circle. So the angle between the translation axis and the normal to the pitch curve is defined as the pressure angle. Now, why is this important? This particular thing is important because the as we increase the pressure angle, what it means is that remember, the normal is the contact force is along the normal, right? So let's go back. So the contact between the normal is the normal direction is the direction along which the contact happens. The contact force is acting along the normal between the follower and the cam profile. So in this case, roller follower and the cam profile. And so therefore, if I now look at the components along the line of translation, I will have basically an f cos theta, which is going to be along the axis, and f sine theta, which is going to be perpendicular to the axis, which is called a side thrust. Now, as I increase this angle theta, the side thrust, the sine component increases, the cos component reduces, but the side component decreases. Now remember that this is going to move up and down in a bearing. So the side thrust is going to push it against the bearing, and therefore this can create, if the force is too high, it can jam the follower against the bearing. So we have to guard against that. You may not know at this stage what bearings and stuff are there, but the translation cannot happen independently. It has to slide in a bush. So when I have a side thrust acting on that bush, the follower can get jammed against the bush housing. So we want to prevent that. So normal guideline here is that that angle should be less than 45 degrees. So when you look at cam design, one of the things when you synthesize earlier, we saw transmission angle in the case of between the coupler and the output link. Same case here, we do the design, then we check whether the whether this pressure angle, which is the angle between the translation axis and the normal at the point of contact to the pitch curve, we want to ensure that that is small, so that the side thrust is small. So this has to be checked. So one of the ways that you could do this is by increasing the size of the cam, but of course that is limited. So the larger the cam is, this the pressure angle reduces. That's one way to do that. We'll also see that one way to do this is to look at offset as a way to achieve this, although offset in one direction effectively increases the pressure angle in the other direction. So during rise, I may have a reduced pressure angle, but during return, I may have a increased pressure angle. But anyway, increasing the size of the cam or changing the offset is one of the two ways to basically achieve this. All right. All right, a few more terms. I'm sure I'm throwing a lot of terms. Please do read this in leisure, because you have to internalize some of the cam language. So when somebody asks you what is pressure angle in a cam, what is base circle of a cam, you should be in a position to understand and answer these questions. This pitch point happens to be the point of maximum pressure angle. So this pressure angle, of course, varies along the cam profile. So the point at which the pressure angle is a maximum on the pitch curve gets called as a pitch point, and the circle that is passing through this pitch point with the cam center at from the cam center, drawn from the cam center, is called as a. So let's visualize this to be point here is where the pressure angle is maximum. Therefore, that is called as a pitch point. Now from here we draw a circle, which is what we have done, which is called as the pitch circle. So so therefore, we have the pitch point and the pitch circle, which are associated with the pressure angle part of it. All right. Okay. I think so. These are the terms that we have introduced. There are some more terms. I have kept it to the bare minimum that is required in terms of cam synthesis and things that you need to check. So we have a base circle. We have a trace point base circle, which is the smallest circle that you can draw tangent to the cam profile from the cam center, which dictates the size of the cam. We have trace point, which describes the follower motion. This is a theoretical point. Again, differs for different type of followers. We have defined what it is. Then you have what is called as a pitch curve for a roller follower, which is basically the locus of the trace point, which is in the inversion, where we freeze the cam and then look at the follower rotating around, and then the curve traced by the trace point becomes the pitch curve. And of course, prime circle basically is the circle that is fit tangential to this pitch curve from the center A. So in the case of a radial follower, the prime circle and base circle differ by the roller follower radius. Then we talked about pressure angle, which is the angle between the translation axis and the normal to the pitch curve. This decides the side thrust force. So if it is larger, then the side thrust force increases and you can have jamming in the bearing. So to avoid that, we should keep this preferably below 45 degrees. And the point of largest pressure angle, of course, is what we need to keep in mind. That is called as the pitch point. And the circle that is drawn from the cam center passing through this pitch point is called as a pitch circle. Okay, so now we have various terms defined in this lecture. In the previous lecture, we had seen the need for cams. Now we have seen the classification of the cams based on follower motion and the kind of followers and some terminology. Next, we say, okay, how do I now define the follower motion? That's the first step in the design. We now first find out what is the required follower motion. So we will go back, pull out the same example, the valve opening and closing as an example of a follower motion, and from there try to design the appropriate cam that will give us the kind of follower motion. Okay, so with this we stop lecture 2.